Yeah. Now come back to our topic. Today we are going to discussing about groundwater pollution. Our India, it's going to be developed with rapid industrialization, population, and the density of population it is increasing, and as well as we need a demand of water resources also. So that here the groundwater it's a gift from our nature, and our challenge and our duty, we have to recharge through the infiltration and seepage with evapotranspiration. Almost 98% of fresh water we'll get from the below the surface, and the remaining 2% of water we are getting from the lakes, rivers, streams, and the reservoirs. Yes, the fresh water it is available below the surface. 90% will get the satisfaction with groundwater, and about remaining 2% of water it's presented in the soil moisture. It is in unsaturated zone, and it is occur above the water table, and it's useful for the plant growth. We know that actually we discussed till yesterday where it is a groundwater occurred. The groundwater it's located is beneath its surface and in the soil pores and in the fractures of rock formations. And every day the human activities are increasing, and constantly it is going to increase with industrial, domestic, and agriculture wastes to the groundwater reservoir. And now it is a stage, all of the groundwater amount, it is going to be polluted, and it is in at a alarming stage. The groundwater contamination is generally it's irreversible. Once if it is contaminated, we unable to restore and we unable to get the original quality of a water from aquifer. So that what's our duty? Our primary duty it is always to better protect the groundwater, and rather it's a basic technology, and we should have to clean up the water from the contaminated source. Ice caps and glaciers, the account for 76.6% of the fresh water source we will getting from the source of earth, and 22.7% from a groundwater, and nearly 0.5% of surface water. Groundwater it is a major source for drinking purpose, and particularly in rural areas, and also in irrigation purpose also. Now our country it's become a good industrial infrastructure in core industries like metal, chemicals, fertilizers, and uh, petroleum. In all the sectors, we were getting the development. Yeah, water pollution, maybe it is divided into the 5 categories on the basis of a storage of a water. One, it is a surface water pollution. Second one is a groundwater pollution. Third one, lake water pollution. Fourth one, it is a river water pollution. Fifth one is a sea water pollution. What it is the differentiation between the pollution and contamination? Pollution, it signifies any degradation of a natural groundwater quality, and while the contaminants are reserved for a pollution, and it's a constitution or consisting of very hazard and dangerous materials. These are all the health these are all the danger for our health. A pollution of a groundwater. If we can define this as a pollution of a groundwater particularly, defined as the artificially induced the degradation of a natural groundwater quality, and the pollution can impair the use of water and can create hazards to public health through the toxicity or the spread of diseases. In contrast with the surface water pollution, subsurface pollution, it is difficult to detect and control, and may persist for decades. Some efforts are increased to prevent the and reducing the elimination of water pollution. Definitely, we need some efforts how we can reduce and how we can eliminate the water pollution. The pollution, it is related to the maximum possibility of a pollutants where it is occurring in the groundwater, and the sources and the causes of a groundwater pollution are closely it is associated with the human use of a water. Yeah, groundwater contaminations, there are two sources. One, it is point sources. Second one, it is non-point sources. In a point source, storage tanks, landfills, pipeline releases, etc. and etc. If you can go into the non-point sources, the agriculture activities inclusion in this one, so that here what is happening, it is going to contaminate, and the contamination originates from the disposal of a groundwater, and following its use of a wide variety purposes. The point source pollution. The point source pollution, it is referring that the contaminants which enter into the water or waterway through a discrete conveyance, such as a pipe or a ditch. The best example for this one, discharges from sewage treatment or a factory. From these, we'll get more and more sewage water. It will be come from that one, and these all are when it's joined into the water body, and it's creating the pollution. When you come into the non-point source pollution, the non-point source pollution, it is refer to diffuse the situations, and according to that it will be done. When you see the non-point source pollution, sometimes it is accumulating with the effect of a small amounts of contaminants, and which are gathered from a large area. The leaching out of a nitrogen compounds from agriculture and which has been fertilized is a typical example. And not only that one, if we can in a particular groundwater pollutions, we may that humans sometimes we can apply the pesticides and chemicals into the soils. They are washed deep into the ground by a rainwater, and it's also getting the underground water, and it leads to the pollution in a underground level. And this means that if we can dig the wells or a boreholes to get water from underground, it needs to be checked for a groundwater pollution. There are sources or causes of a pollution with regarding to their occurrences. Those sources are municipal source and causes, industrial sources and causes, agriculture sources and causes, miscellaneous sources and other causes. In a multiple sources and their causes, in this case, particularly it will be speaking about a severe leakage. This there are again it's a depend on the defective of a severe pipe. Sometimes maybe it is leakaging by the tree roots and rupture from the heavy loads, earthquakes, and loss of a foundation support. These are all the causes for severe leakage. And again, it is introduced the higher concentration of a BOD. BOD means biologically oxygen demand, and COD, carbonate demands, including with the nitrate, organic chemicals, bacteria, and other heavy metals which are introduced and enter into the groundwater. And second one, it is liquid wastes. In a liquid wastes, the sources are domestic wastes, disposal well industries, storm runoff material, and it is giving the result, introducing the bacteria, virus, trace elemental, and heavy and toxic metals, inorganic and organic chemicals. These which are giving solid wastes. Third one, it is a solid waste. The main source, it is the solid wastes. The main source, it's a landfills, and it's a result. It is leached from landfills, and it can pollute the groundwater. The leachate, it is inclusion of iron, manganese, nitrates, trace elements, etc. and etc. The second one, it is industrial source and causes. It is having a liquid wastes in a from the industry sources. Industry wastewater, it is discharged into the pits, ponds, lagoons. Through this one, here slowly it is going to be percolated into the deeper level of its surface, and that is the cause. It is also cause. When it is reached the groundwater, then it is going to be contaminated. So that it's a industrial sources also main causes. What about that result? It's introduction of that one hazardous and toxic industrial wastes releasing into the groundwater. So that definitely we can say these sources are creating the contaminated in a groundwater. Sometimes the tanks and pipelines, if they will get a leakage, the main source, it is from the fuel oil tanks or petroleum products, and these petroleum products, it is released from the industrial pipelines in the tanks and some gasoline stations. The result, it is immiscible liquids like oil and petroleum. The radioactive wastes, that means it's releasing the radioactive wastes also, and these radioactive wastes, it's reached to the water table, and it is also going to creating the groundwater pollution. Next one, it is mining activities. The mining activities, and that is also creating a major contamination into the groundwater. And how we can control all these things? How we can control? We have to maintain some proper methods and discharge methods. We'll have to maintain that. And another one, it is agriculture source and their causes. If we go into this is irrigation and the return flows, irrigation return flow drains to surface channel, and these are all joined into the underlying water. The result, it is increasing the salinity of a groundwater. It's increasing the salinity of a groundwater. If they mix, definitely it is increasing of salinity of a groundwater. And then not only that one, it is increases the amount of bicarbonates, sulfates, chlorides, nitrates in a groundwater. So the agriculture products also, in agriculture also, if we can use the more and more pesticides and fertilizers, and that is also going to be create contamination in a groundwater or a pollution in a groundwater. Animal wastes. The animal wastes and these wastes it's released from the slaughter houses. The natural assimilative capacity of a soil it's become the over taxed, and the soil it is going to be converting or changing into the more having the salts, organic loads, bacteria, and these are all the transporting into the soil. The nitrogen and the nitrate, it's the most important persistent pollutant that may it's reached in when it is reached into the water table, then it is going to be changed or the worsened water quality it's lost. Yeah, when we are using the fertilizers and soil amendments, the leachate of a phosphate and potassium fertilizers, the leachate of soil amendments like lime, gypsum, and sulfur. If they are mixed or if they are melt into the soil or with the soil particles, and the soil it is going to be changed or the soil it is going to be morphosed as a salinity. So that here the salinity it is increasing when the fertilizers or the pesticides if they will be uh, add or joined in that soil that is going to be contaminated. And some miscellaneous urbanization. Yes, definitely the groundwater pollution can occur in a both rural as well as in urban areas, and it is affecting by the different chemical compositions or biological and chemical reactions, and the density and the distance it's coming from the discharges of a different industries or different areas. Suppose if you can see the spills and surface discharges, the casual activities which are includes leaks from pipes and valves, and under control the waste disposal material, which are intermittent dumping of fluids on the ground, flushing hazardous and flammable liquids into the water. It's suppose if washing a aircraft with the solvents and the spills of fuels of a at airports, which can coming from a different source, and the layer it was formed of hydrocarbons, and it's floating on the water table. So that this is a one chance the water it is going to be polluted in a water table. stockpiles the solid material, and suppose which are a solid washes which are placed for a temporary or a permanent storage and frequently stockpiled near industrial plants, construction sites, and large agriculture operations. Rainfall, that's also. If it is a rainwater, it is from falling under the unsheltered stockpiles and it causes to leaching to occur into the soil. And the transportation of heavy metals, salts, and other organic and inorganic constituents which are act as a pollutants, and these constituents will be joined in a water table, and again the water is going to be polluted. Septic tanks and cesspools. Septic tank, the water, if it is in a tight basin and it is intended it getting the decomposed the domestic sewage, and it is a discharge into the uh, biological active zone, and it's reached to the soil mantle and through a subsurface in the process of a percolation system. So that here the water amount, whatever it's a sewage water or whatever it is, due to the percolation system, it's reached to the subsurface of a water and it is going to be contaminated. And cesspools, a large buried chamber with a porous, the wall it is designed and to receive and percolate a use amount of a raw sewage. So this is also one cause. Roadway dicing. This roadway dicing, the application of this dicing salts into the streets and the highways in a winter, it's can creating the pollution in a groundwater. And the salts are it used to maintain the streets and highways in the safe driving conditions throughout the winter, in particular in snowfall regions. Suppose if it has a NaCl amount, the NaCl accounts for the most of the applications. With a CaCl, it's a remainder. The salts only not only it's a producing and it's a degradation of a groundwater quality. So that the salts, if it is a reach to the groundwater in a solution after it's a spreading on a road base, and it's a form as a or it's a form as a stock piles. Interchange through wells. Because wells from highly permeable vertical connections between aquifers, they can serve as avenues for groundwater pollution, where inadequate attention is given to the proper construction, sealing, or abandonment of different walls. Saline water intrusion. A saltwater may invade the freshwater aquifers to create a point or a diffuse pollution source. The saline water, it's a more common pollutant in a groundwater. We know that the mechanism are responsible for saline water, where it is inclusion fall into the three categories. One, it is a reduction or a removal of a groundwater gradients, and second one, it is a destruction of a natural barrier. It is separate the fresh and saline water. The construction enable to tidal water its advance inland and percolate to the freshwater aquifer. And third one, it is occurs in a subsurface disposal of a wastewater saline, such as a disposal wells, landfills, and other waste depositories. The occurrence of a saline water intrusion causes it's having the high TDS, sodium, chlorides, and magnesium. And surface water. A polluted surface water body that contribute to the groundwater recharges. It's become the major source for the groundwater pollution. And some pollutants in a groundwater tend to be removed or reduced. The rate of pollution, it's a attenuation. It's a depend on the type of pollutants and on the local hydrogeological situation. Yes, the local hydrogeological situation, it's also playing the very important role when it's water, it's going to be either contaminated or not. Some salts, if it will be, or those salts which are melt, and these salts are also creating the water contamination. And some suspended matter. The suspended matter, some pollutants are substances, particles, and the chemicals that are not easily dissolved in a water. So these type of substances which are not dissolved easily in a water, so it's a remaining as a solid material in a water, and this type of a material, it is called as a particulate matter. And some of the suspended pollutants, slowly it's resettled under a water body, and definitely we can say it is a very harm, and it's hazardous to the aquatic lives. So that the suspended matter, it's also very important to creating the pollutants in a water bodies. Yeah, chemical water pollution. The chemical water pollution, many industries and farmers works with the chemicals that end up in water. It's a common with the point source pollution. It includes the chemicals that are used to control the weeds, insects, and the pests. Metals and solvents. Metals and solvents from industries, and these can pollute the water bodies. These are poisons to many forms of aquatic life and may slow their development and and some of the infertile and kill them. and some natural inorganic constants, arsenic fluoride, like arsenic fluoride, selenium, radon, and uranium are examples of health relevant naturally occurring groundwater constants. Their concentrations in the groundwater itself strongly, and it's depend on their hydrological conditions. How we can prevent this water pollution? We can prevent with the dealing of the water pollution, inclusion of a government and local councils. They should be involved. How we can prevent the water pollution, they need to be discussed. And never throw the rubbish or waste material away anyhow. And we should throw into the in a correct waste bin. If suppose if there is none around, please take it home and put into your trash can. This includes the places like the beach, riverside, water bodies, and all those. Unnecessarily, we do not to throw the chemical soils, paints, and other waste material where into sink into the drain or in a toilets. In many cities, your local environment office it can help. It can help with the disposal of medicines and chemicals. Check with your local authorities. Check with your local authorities if there is a chemical disposal plan for a local residents. If we can use chemicals and pesticides for into our garden and to farms, and we should be mindful not to use overused the pesticides and the fertilizers. This will reduce runoffs of a chemical into the nearby our water sources. So that we start to looking at options of a composting and using organic manure. Yeah, wastewater treatment or sewage treatment. The wastewater from flushing the toilets, bathing, washing sinks, and general cleaning purposes is going to the down and drain the into the pipe, which joins a larger sewer pipe under the road. The larger pipe also is joined the major pipe that end leads to the treatment center. And next one, it is a artificial recharge. The artificial recharge, how we can recharge the water artificially. And it's also one of the method to change and modify the hydrological cycle. And it's providing the groundwater in excess amount in availability of natural process. And it is complete and by augmenting a natural of infiltration of a precipitation or a subsurface into underground formations. In another method, we use the construction. When we are going to construct the ponding or spreading of a water by artificially, it's changing their natural conditions. Yes, there are some favorable and conditions of a natural or artificial recharge. The first one, it is a formation of a sand, gravel, or highly fractured rocks, either underground or exposed over a large area in stream channels. The presence of a convents, fractured and faulted zones, or we have to identify the numerous small cavities in rock formations under the underground, or it's maybe in exposed on the land surface. And crusts or sinkhole hole topography also. This is also useful to increasing the recharge. And one more thing, it is the absence of a barriers for installation of recharge wells, dams, diversion, or other recharge structures. A wide braided streams and a broad alluvial fans and glaciofluvial deposits may present the excellent opportunities for a water spreading. In an artificial recharge method, we can do by the flooding, water spreading into the basin and ditches and furrows in irrigation purpose. And sometimes we may modify the streams or natural channels, and we create the percolated dams, pits, shafts, injection wells, and a induced recharge. These all are methods which are useful for increasing of a groundwater level in artificial recharge. And one more, the quality of groundwater, how it is going to be increased. The quality of injected wells are very important. Suspending the soil or biological chemicals impurities or dissolved air and the gases. Turbulence and the temperature of both aquifer and injected water will have an effect on the life and efficacy of a well. Corrosion of the well screen. The large amount of dissolved air in the recharge water, it's tend to reduce the permeability of aquifer by air bonding. So that the injected water should have the temperature only it's slightly higher than the temperature of the aquifer. And not only that one, recharge pit. In a recharge pit, if you can construct the recharge pit more and more, that's also useful for the increase of a groundwater. How we can manage the groundwater? The maximum development of a groundwater resources for a beneficial use involves its planning. It attempts an entire groundwater basin. Yes, we know that basin, it is a large natural underground reservoir, and the availability of this groundwater we can utilize for different purposes. And when you come into this is a management, in your management things, how we can develop and operate this basin. And this is not only involvement of geological and hydrological conditions, but also it will involvement of economic, legal, political, and financial aspects. How we can manage this basin? There are some concepts are there. Yeah, the groundwater reservoir is widely used to denote the places where the groundwater is accumulated under the different conditions, and it's to make it suitable for development and use. As there has been no standard, universally it is accepted the term of a groundwater reservoir. Groundwater basin, aquifer, water bearing zone, groundwater district, and a groundwater area. These terms are using now. And it is applied in a rock ranges from the few meters to the thousands of meters in a thickness and distribution over the areas. And it's ranging from the few hectares to the thousands of square kilometers. And the hydrological equation, it has a surface inflow. That means the area it has a inflow plus subsurface of inflow and adding of a precipitation. And the water it should be imported from different sources and decreasing the water storage plus decreasing in groundwater storage. And it is equal to that surface outflow, subsurface outflow. How much we are using, that is a consumptive use plus exported water, how much we are exporting to outside. That means at outside we are using for different purposes. Plus increase in surface storage plus increase in groundwater storage. This is a principle. Based on this principle, we can manage the water basin. How much it is coming to outside? It's an inflow, surface inflow, and it should be equal to the surface outflow and as subsurface outflow. And how much we are using. Based on this management, the water level we can see. How we can manage the groundwater? The demand of a groundwater, it's a recent decades. It has led to the development of various and variety of strategies for managing subsurface water and making the efficient use of available underground
storage space. It is important to recognize on a regional basin that groundwater and surface water, it's a consisting single unified source. Yes. And what it is that today what we are thinking about a groundwater, and tomorrow what about that? So that based on this, the depletion, it is impacting to the one to another. The quality of a water, if it is available from an aquifer, it's depend mainly on the amount of natural recharge, the rate of groundwater, how it is coming, and how much it's withdrawn. There are three stages to the development of an aquifer. In initial development stage, when groundwater it's a pumping, it's a less than a natural recharge. It is coming from, or it's a recharge only by the spring and river flows, which are affected marginally. And full development stage, when groundwater obstruction, it is equals to natural recharge. It is in a longer decades. The impact of a groundwater pumping on surface water bodies, it's may be the critical during the later stages to development of a aquifer. It is not managed properly. Withdrawal of groundwater, the amount and spatial distribution of a groundwater pumping in a basin, it should be organized ideally so that to develop a sustainable yield in a long term. Some geological aspects it's required. Those physical characteristics of water bearing formations, thickness and specific yield of water bearing deposits, the greater thickness and higher the specific yield of the deposits, the larger storage of capacity, and hence a larger volume of the water will be available in these deposits. Permeability and transmittivity. It should be present definitely in the water bearing deposits and in adjacent the well fields. The higher permeability and transmissibility of aquifers formations. The higher capacity of these formations to transmit the water of that area, heavy groundwater, if it is withdrawal in a field. Lithological barriers, and these are the relatively impervious horizontal clay layers or cemented horizons that radically control the vertical movement of a groundwater. And we should have aware, or we should have a knowledge about the clay layers. It is essential to understand potential and the land surface of subsidence. And one more, it is structural barriers like some faults, faults, and which may impede or completely block the lateral movement of the groundwater to the well. But some situations they may increase the groundwater movements. If it is rocks which are associated with fault rocks, fault formations or fault structures. How we can recharge the groundwater artificially? There is some concept. Artificial recharge projects which are designed to serve one or more the following purposes. We should maintain the natural groundwater as an economic purpose, coordinate the operations of surface and the groundwater reservoirs, provide subsurface storage for local or importers of surface waters, reduce to or stop the significant and land subsidence, provide a localized subsurface distribution system for established wells, conserve or extract energy in the form of hot or cold water. In the most of the situations, artificial recharge products not only serve the water conservation, and it is a mechanism of and assisting the overcome the problems which are associated with overdrafts. The artificial recharge it's accomplishing by applying the water into the soil infiltration and the downwards movement through the unsaturated or widow's zone of a groundwater. There are various methods were developed to recharge. Methods were developed. The most widely the practiced method can be described of a groundwater spreading and releasing water over the ground on a ground. If we can release the throughout the ground, slowly the water it is percolating through the infiltration into the ground. It's percolating to the water table. And the field studies of spreading, and it's having the many factors when it is the rate if it is going to be increased, the water is enter into the soil from the quantitative standpoint, arranging of recharge and the length of time that water is in contact with the soil are the most important. Induced recharge, direct method of artificial recharge. It involves the conveyance of a subsurface water to some point where it is enters into the ground. Distinguished from these, the methods induced recharge accomplished by the withdrawing groundwater, and the location we should adjacent to that location where it is that it is suppose adjacent to the river or a lake, lowering of a groundwater level induced enter the ground from the subsurface and from the source. Watershed management. The concept of this watershed management, it's very important for restoring of water. And the concept, it was developed in the 19th century to restore the alpine conservation movement of those who have pushed the water shed to the surface. The land restoration and torrent control technique and the vegetation manipulation and soil and water conservation techniques along that conceptual theory model, and it's a depend on the basis of watershed strategies. What is watershed? Watershed, it is a spatial unit with complex relations, and it is defined by the stream pattern. With the rainwater, it's collecting through the surface and subsurface runoff and culminating at the common point down the stream. If you can say in other words, watershed, it is a geohydrological unit draining at a common point by system of streams. And the watershed, it compasses all that land and water area that contributes the runoff at a common point. And it is topographically, it is a delineated area. It's draining into the single channel. The depth of water shed, it may extend from the top of the vegetation and to the confining the geological strata under the surface. Yeah, every watershed, it has a fingerprint. No two watersheds are same. Strictly, it's referring that dividing, separating one drain to the another drain. Watershed has been identified with a drainage basin or in a catchment area. Yes, we should have identified these nearby the drainage basins or in a catchment areas. It has a small streams and it's leads to formation of the subwater sheds with a larger stream. The watershed maybe it's a nearly flat or it may be highly undulated. Each and every water and land area is a part of one watershed or the other. Human and animal populations are a part of the watershed community. The geological or hydrological regime of the watershed, it has a inalienable relationship with the flora, fauna, soil, and climate on a temporal basis.
There are three types of watershed. If we can classify that, it's three types. One, it is a suburb watershed. The size approximately it has a 100 to 500 square kilometers. And second one, it is a milli watershed. The size is about 10 to 100 square kilometers. And third one, it is a mini watershed. The size it is less than 1 square kilometer. It has some specific characteristics. If we can elevate it that, we can use some terms. If we can elevate it that, we can use drainage of that area, which are all considered as a physiography. And second one, it is edifice conditions. Third one, it is land use. Fourth one, wastage to cover. The area how it was covered by the vegetation and greenery, forestry, plantation. These are all playing a very important role. And socioeconomic factors, rainfall, agriculture land, grassland, forest land, shifting cultivation, and unscientific mining and construction. These are all the factors. And one more thing it is, groundwater model. The aquifer modeling techniques are required for a development of a conceptual understanding of a groundwater system or preparing of a aquifer responses. It's a depend on the recharge and draft scenarios. And the previously how much we have used and presently how much amount of water we are using from the aquifers, and that's also we should consider. The groundwater models are computer models of the groundwater. It's a flow systems, flow channels, and we can develop. And the groundwater models, which is useful to simulate and predict the aquifer conditions. A groundwater model, it's maybe scale or a model or an electric model of a groundwater situations, how the aquifer it is going to be formed, and what is the type of aquifer. These all must and should take a consideration when we are developing the groundwater model. And it's also used to predict the effects of hydrological changes like groundwater abstraction or irrigation developments. And the changes it's depend on the behavior of aquifer and are often named the groundwater simulation models. And there are types of modeling. One, it is a physical or analog model. Second one, it is a mathematical model. In a physical model, sand model, viscous model, membrane model. Fourth one is a thermal model. Fifth one is a electrical model.
When you come into the mathematical model, it's a two types. One, it is a analytical model. Second one, it is a numerical model. In a mathematical formulation, if you can see this one, the partial differential equation, it's describing the two-dimensional groundwater flow. Maybe it is expressed in dou by dou dy into t and dou h by 2y plus dou by again dou y into ty, and it is divided by the dou h by dou y plus, and it is equivalent to the s into dou h by dou t plus or minus w. Here t, x and ty, these two are expressing the transmittive values in different directions, x and y directions. And h is equal to, it is a hydraulic head. S is equal to storage, how much it is going to be storage. It is called as a storativity. W is equal to the groundwater volume flux per unit area, and xy it is indicating the coordinates, Cartesian coordinates. That means directions. Here again, there are some data. It's also required for modeling. And the number of layers, how much they were presented in that aquifer, either maybe that is a confined or unconfined. In a confined, if you can see in this one, the transmittivity and storage coefficient. In a confined, if you can see that has transmissivity and the storage coefficient of the layers, and it has a constant entire simulation. And another one, it is unconfined. Its transmissivity of layers are different. It is calculated from the saturated thickness of hydraulic conductivity, and the storage coefficient is a constant. It's valid only for one layer, up to one layer. And importing elevations, we'll take into the consideration of the surface elevation. It's as a contour. The value of that contour at each cell at the center of a block, it is noted that xy coordinates we should import it into the model or as a ground elevation. The conductivity, storage, and porosity depend on these. Also, we can do that. Observations and pumping well, these are all required. And 1, 2, 3-dimensional model, semi 3-dimensional model also it's required. So that we
Sir,
can
next class on sir. Time of class
yeah,
end.
it's finishing. Okay, thank you. Yeah, now I'm stopping here. It's finished all the total syllabus.